So, good morning. I am Professor Jabbar Samuel, Assistant Professor, Department of EEE, ROHINI College of Engineering and Technology. So, today I would like to share something about the phase control rectifier. What do you mean by rectifier? Rectifier is a device which converts AC voltage into DC voltage. It is classified into uncontrolled rectifier and controlled rectifier. What do you mean by uncontrolled rectifier? So in the rectifier circuit, if you use diode as a semiconducting device, the output voltage cannot be controlled. Why? Whenever the device is forward bias, which automatically conduct, so we cannot control the output voltage. So control rectifier means in the rectifier circuit we use thyristors, then we can easily control the output voltage, and the device is known as control rectifier. So this is the classification of rectifier. Rectifiers are classified based on three categories. One is based on input supply, and based on quadrant operation, and third one based on number of pulses. Based on input supply, which is classified into single phase rectifier and three phase rectifier. So based on quadrant operation, which is classified into first quadrant converter or semi converter, second quadrant converter or full converter, fourth quadrant converter or dual converter. Okay, so in first quadrant operation, the voltage and current is positive. Okay, like based on number of pulses, which is classified into 1 pulse, 2 pulse, 3 pulse and 6 pulse conductor. So pulse operation means for each cycle how many number of pulses are given to operate the semiconducting device. So application of rectifiers are DC motor speed control, then DC supply for inverters, electrochemical process, DC traction and high voltage DC transmission. So this is the basic block diagram of a single phase half wave rectifier with R load, which consists of a thyristors which are connected in series with the input supply and a resistive load. The voltage rating of the SCR is minimum. So initially the AC voltage is stepped down by using this reduce at this point. So the AC voltage is given to the thyristor. So you know that see the waveform, the first waveform show the input voltage, that is sine wave. Okay, so here a concept is very important, that is firing angle. What do you mean by firing angle? It is the angle between zero crossing of input voltage and the instant the thyristor is fired. Once again I repeat, it is the angle between zero crossing of input voltage and the instant, that is time, voltage is zero crossing at the beginning, that is at point 0. So we don't apply gate pulse to this transistor. At a firing angle alpha only we apply gate pulse. Okay, so whenever we apply gate pulse, then only the device conduct. Okay, at the output side the voltage occurred. At the end of positive half cycle, the voltage goes to 0 due to the nature of power supply. So automatically the thyristor is turned off, natural commutation. So after that the voltage is, so for this negative voltage the thyristor is reverse bias and does not conduct. So in the output side the voltage is 0. So the positive half cycle The thyristor is forward bias, and based on the firing angle applied to the thyristor, which conduct and output voltage appears. So in this type of rectifier, in only positive half cycle only the AC is converted to DC. That's why it is known as half wave rectifier. Okay, the output voltage of this rectifier is VDC equal to 1 by 2 pi. The conduction interval is from alpha to pi. The voltage is Vm sin omega t into d omega t. So Vm is take constant, which take out. So Vm by pi, apply the limit minus cos omega t, alpha t into limits alpha to pi. So solve this equation. The final output is VDC equal to Vm by 2 pi 1 plus cos alpha. So this is the average output voltage of rectifier. Okay. Thank you for your patient listening.